Hello everyone. This lesson is going to give you a crash course on 11.5. There's just 6 problems that I would encourage you to learn how to do. This one will feel kind of awkward to many of you because it's just it uses some steps that you're probably not overly familiar with, and which makes it all the more important if this class is not your exit class. And if you're headed to calculus eventually, this whole idea of substituting one function in for another to make a problem more simple is going to come up multiple times during your calculus experience. So this is the one I put on the homework, and this type of example is the one that I chose for the test. So you're not required to learn all of the different types, and I certainly don't teach you every scenario that you might encounter in the book. But the idea of substituting, again, is something that you won't stay foreign for long. Even if you're headed to college algebra or pre-calc, you'll probably experience this just a little bit. So the idea behind solving for substitution is that we try to make a difficult equation look a little bit more simple by replacing the middle term and the variable of that term with a different letter. And I think once I stop talking and just start doing, it'll make a little bit more sense. So you get to choose the letter. You could choose W, Y, the initial of your name. I could care less. So let Y equal, and it's always going to be whatever variable here is after the coefficient. Remember how it's like ABC for the quadratic formula? And so whatever the variable is after the B is what you're going to come over here and let that equal. And then imagine that you were going to square both sides of this, which is a perfectly valid move. You would have y squared equals x to the 4th. Well, that's what this is x to the 4th. X to the 4th. And so now I can substitute kind of everybody. Instead of x to the 4th, I'm going to write down y squared. I'm going to change my variable. So we have y squared minus 10. Remember, this is what I changed initially here. Y equals x squared. So I'm going to put a y right there. Plus 16 equals 0. This should be something that you can factor. This one might be a little confusing. It gets worse as we go along. But even if you know how to factor this piece that's x to the 4th, this one is much simpler. And so now you just factor and solve like you normally would. Y minus 8, y minus 2. You solve it, you're going to get y equals 8 and y equals 2. And now once you get to that point where you have your new variable actually equaling a number, now we're going to substitute back. So right here, substitute back. Replace the original variable you had going. So if you look up here, we had y equals x squared. So I'm going to say, okay, well, instead of this y, it's going to be x squared equals 8. And instead of this y, it's going to be x squared equals 2. And so now what we do is we solve for the initial variable, the original variable, which is what we wanted to do the whole time to begin with. And so in order to solve something that has an x squared, you're going to radical both sides. So x equals, and then I'm going to simplify that 8 by breaking out any pairs I have. 8 comes up all the time, so you're probably going to see pretty quickly that we're going to end up with 2 radical 2. Don't forget the plus or minus. So we have 2 answers there. On this side, if I square root both sides, the square root of 2 cannot be simplified, so you have x equals plus or minus just radical 2. And I don't know that you'll remember all the way back, but when we first learned how to factor, we talked about how if this was a 3, that you would have 3 answers. If this is a 4, you should anticipate 4 answers. And I have 2 answers here. The plus or minus 2 radical 2 option. Here's 2 answers. And here's another 2 answers. And so that does add up to 4. You guys try this one. So pause and try. Let's mix it up. Let's mix up the colors. Let's mix up the letters. Let's let m equal x squared. It's always going to be this piece right here. So then m squared equals x to the fourth if I square both sides. So this becomes m squared minus 13m, plus 36. If I factor that, I'm going to get m minus 9 and m minus 4. If I solve, I'm going to get m equals 9 and m equals 4. And now when I substitute back, plug it in with the x squared, solve both sides by taking the square root. I gave you really nice numbers. You're going to have, don't forget the plus or minus option. And then over here, if you substitute back x squared and you square root both sides, you get x equals plus or minus 2. So that's the one I put on the test. If you would like to watch further for just kind of more examples, because you know that you're going to head into pre-calc and calc, stay tuned. Sorry, I had to pause. All right, here we go. Next one. All right, so this one does definitely look different. Again, the b is a -1 in this scenario, so we're picking the variable after that for our substitution. So we could choose w for a letter. And so that is the piece we're going to replace. And think about what would happen if I would square both sides. W times w is w squared here on the left, but on the right, that would just cancel that out, and w squared would be x. So this, bear with me here while I color code everything. This piece here is always going to be what you get after you square it. And when you substitute, you're always going to get something nice looking that looks like something we have factored in the past. So, oh, because of this recorder, now you have to just, I can't erase that, so sorry. All right, so when we substitute, it looks like this. W squared minus 1 square, not square root, minus 1w minus 20 equals 0. If you don't like to look at that one right there, don't write it. But this is definitely something we know how to factor. Two numbers that multiply to 20 that add up to -1 are a -5 and a +4. So go ahead and solve what you know. And now we're going to substitute back. So originally that w was the square root of x. So now we have the square root of x equaling 5. And over here, we have the square root of x equaling -4. How do you solve something that's underneath the radical? You square both sides. So we get x equals 25. We need to make sure that checks. So come up here and think through what it would be if it was 25. 25 take away, the square root of 25 is 5, so 25 take away 5, take away 20, that's okay, that checks out. All right, if you need a little bit more for that one, feel free to work it out, convince yourself that what I'm saying is true. And over here on this side, when I square both sides, and that breaks out, we're gonna get x equals 16. I don't anticipate this working. 16 minus radical 16 minus 20 equals 0. I think because we're squaring the negative right here, that's usually the type that doesn't work. See, that's going to end up being -8, and -8 is not 0. And so this one gets thrown away. So you only have one answer here because of the nature of the question. Here's your try. Do the same thing. Square both sides. Replace it. So y squared minus 3y minus 18. factor it. Set each piece equal to 0 and solve. And then go back and substitute in what the initial variable was. Square both sides. You get x equals 36. Square both sides here. Square root of x equals -3. I wouldn't anticipate this one working. Don't forget to square with that negative in the parentheses. X equals 9. I'm going to check the 9 here. 9 minus 3 times the square root of 9. The square root of 9 is 3. 3 times 3 is 9. 9 minus 9 is already 0. Before I take out that 8, this one is not going to check. 36 probably checks. The square root of 36 is 6. 3 times 6 is 18. So that turns out to be nothing. And if I'm asking if that's equal to 0, yes, 0 does equal 0. So this is the only answer to the question. All right. I've saved the trickiest for last, but the steps remain the same. So whatever is behind that B number, whatever the number the B is what you're going to substitute. So let's make it F. So F equals x to the -1. So if I square both sides, imagine squaring. If I take -1 to squared, I'm going to end up with f squared equaling x to the -2. Oh, well, that's what that is. So this kind of gross thing can be replaced with something that we know what to do with. F squared plus 6f plus 8 equals 0, because originally it looked like that. Factor it. Solve. Okay, and then we have to replace it. Now, what is x to the -1 power? Well, anything to the -1 power, remember we're going to flip it like that. So instead of x to the -1, when I go to replace it, I'm going to write 1 over x. So right here, I'm going to say, okay, this is equal to 1 over x. And right here, I'm going to say, okay, this is equal to 1 over x. And it looks pretty messy right now, so I'm going to rewrite that. I'm going to say 1 over x equals -4 over 1. 1 over x equals -2 over 1. And if you remember how we learned how, oops, sorry, don't know why this is suddenly not letting me just kind of move around. Suddenly my slate seems to have taken on a mind of its own. But we are going to cross multiply. So we are going to cross multiply right here. Oh, look, it's just randomly changing color as well. Let's try one more time. 1 over x equals -4 over 1. We're going to cross multiply this. So -4 times x is -4x. 1 times 1 is 1. Divide by -4. Divide by -4. And we're going to get x equals 1 over -4. Let me see if I can't erase this now that things are working. That was such a weird little glitch there. All right, and then over here, let's rewrite it. 1 over x equals -2 over 1. So cross multiply it. -2x equals 1. So when I divide both sides by -2, I get -1/2. All right, and once again, remember that -1 over 2 and -1/2, and kind of that negative being in the middle, and 1 over -2, there's absolutely no difference. Those are all the same. So Don't think you got it wrong if you put the negative in the different part of the fraction. All right, here's your try. Okay, last one. Here we go. What letter should I use? Let's use Y. So we're going to make Y equal to this piece right here. So then Y squared equals x to the minus 2 after I square both sides. So this always becomes the new variable squared. And this always ends in just that new variable. And this is definitely something that we can factor. Be careful because 4 and 6 add up to 10 and 12 and 2 subtract to 10. So based on the signs, it has to be 12 and 2. Because 4 and 6, this would have to be a positive. So our two answers are negative 12 and positive 2. And then remember that x to the minus 1 power is really just 1 over x. So when I go over here and I replace it, I'm going to replace it with 1 over x. You might even consider rewriting it. So 1 over x equals negative 12 over 1. So when I cross multiply, I get 1 over negative 12. It's not always going to be a 1. Think about if you had like a slip and slide. You could have a fractional answer right here. And then it would work out to be a little bit different. So it just is coincident. I just left the factoring. I tried to make the factoring as simple as possible. But if you had a fractional answer, it would be not 1 over a number. So that's it. That wraps up 11.5. I think I'm saying the right section. And I hope that's helpful. And again, there's just so many different types of substitution, but I wanted to expose you to a few. So take care, everyone.